Morning again. Welcome to our live video webinar about our gas sensors. As a reminder, this webinar is being recorded, so if you have to leave before the conclusion of the webinar, we will be archiving it and putting it up on our website. And everyone who is signed in to the webinar will receive an email tomorrow with a link so you can view it in its entirety if you have to leave early. Also, a heads up and maybe an apology in advance. So we do have some construction going on in our office. We're expanding and we're adding a few new offices. So if you hear some banging or a little noise in the background, I apologize in advance. We're not recording this in a bowling alley or an artillery range. We do just have some people walking around up above us, and so hopefully no one will come crashing through into the conference room here while we're doing our webinar. Today, we're going to talk about our gas sensors and go through our full line of both CO2 as well as toxic and combustible gases. These parts of the industry have been growing at a more rapid pace than the industry as a whole over the past several years. So we've been seeing more and more demand for these types of products in the marketplace, and we've been fielding more and more questions from our customers and from engineers. So we're going to be going through the full product line, and if you have questions, feel free to submit, and we'll get to those questions at the end of the presentation. We're going to start today by talking about our CO2 sensors. And we have a new small compact CO2 sensor in our Aries or our R2 enclosure for wall mount CO2. And it's preset to a 0 to 2,000 parts per million range, and it's also available in a duct mount configuration, which would look like this. These CO2 sensors feature a full 5-year warranty and a self-calibrating software that eliminates the need for routine maintenance and routine calibration after they've been installed in a field. I'd like to talk about this calibration software for a minute because it is a feature of our CO2 sensors that does separate them from competitive products, and there is some misperceptions and some confusion about what this software can do. What it does is it's called ABC logic, and what it does is it trends the low level versus the high level of CO2 in a given space over a rolling 14-day average. So it basically trends that low level and high level of CO2 each day, the unoccupied versus the occupied levels of CO2, and then it calibrates based off that low level. It auto zeros itself based on the unoccupied levels of CO2 in the space, and it trends that over a 14-day average. So if there's any minor changes in the occupancy of a building, it takes that into consideration. So what that does is it prevents the need for future or periodic recalibration of these sensors. But it does not work well in areas where you have a 24-hour occupancy of a building, like a hospital or an office building with multiple shifts. So to take that into consideration, these sensors do have the ability to turn that software off, and then there is a mechanism to allow you to do periodic calibrations with this sensor. But for the vast majority of applications where your building is unoccupied at least part of the day, schools, office buildings, retail, this self-calibrating software, the ABC logic, prevents the need for routine maintenance and periodic recalibrations. This is a patented technology, so there's only a few people that are licensees of this patent. So there are a lot of other competing technologies out there. And so there are people that use what's known as a dual wavelength, where it uses basically two CO2 or two infrared beams inside of the CO2 sensor. And while that is somewhat effective in reducing the drift, it does not eliminate the need for periodic recalibration. So the ABC Logic software is the only feature in CO2 sensors that eliminates the need for periodic recalibration while maintaining an accurate CO2 output. So if you've got additional questions or you want samples of these products, we're certainly happy to put them in your hands. This CO2 R2 sensor is available, and it can be paired with a 10K thermistor. We can do a temperature set point and override all in one small and compact enclosure. And it's backed by our 5-year warranty, which is the same as all of our other products, or I should say most of our other products, all of our temperature, humidity, pressure, and current sensors are all backed by a full 5-year warranty on the entire unit. We have, going forward in our CO2 line, we have the A-Sense and the E-Sense lines, and these are also backed by a full 5-year warranty and include the ABC Logic self-calibrating software. These units give you the option of adding an LCD to the enclosures, both for room and duct. The A-Sense gives you the option of adding a relay to the circuit board, and you also have an analog temperature sensor built in with the A-Sense unit as well. You also, on these units, you have the ability to change the range from 0 to 2,000 to 0 to 5,000 or beyond. The CO2 R2 that we talked about in the previous slide, that one is fixed at a 0 to 2,000 parts per million range, whereas these two options give you the ability to change the range for more industrial sources of CO2. We also have an outdoor CO2 sensor, and that uses the eSense board, but it's packaged into a waterproof, weatherproof enclosure that has an internal heater. And there's been an increased demand for outdoor CO2 measurement because a few years ago, ACI changed its recommendations for CO2 measurement, where it used to be the requirement was to add ventilation when CO2 got above 1,000 parts per million. But ACI's recommendation changed to a number that is 700 parts per million above outside air. So therefore, now there's a need to measure outdoor air CO2 sensors. And the nature of the CO2 sensing element is that it has a very limited temperature range that it operates effectively in. So we created an outdoor unit that has an integral heater so that it heats the air to bring it up within the operating range of the CO2 sensor, so you can get an accurate and stable reading in an outdoor enclosure, especially in areas where it can get very cold, like here in Wisconsin. This sensor is fixed at a 0 to 2,000 parts per million range and has a full 5-year warranty like our other CO2 sensors that we've talked about. We also have a new wall mount CO2 sensor that is a combination temperature, humidity, and CO2 in a sleek package with a touchscreen LCD. This is called our T-Sense, and it can give you an analog output for temp, humidity, and CO2, or a backnet output with a number of user configurable features using the touchscreen right on the display. Moving on to our toxic and combustible gas sensors. The M5 series is our baseline of toxic or combustible gases, commonly CO and NO2. And this is a small, inexpensive, sleek wall mount gas sensor that's available with an analog output, or you can get a relays and LCD display on this package as well. It's low cost, it uses an electrochemical sensor, and it has the option to include relays and an audible buzzer alarm built right into the enclosure. Our Q5 and B5 series are shown here, and these are also available in a number of toxic and combustible gases, including but not limited to hydrocarbons, as well as ammonia, CO, NO2, hydrogen, oxygen, nitrogen, and a number of other gases. And this gives you a nice compact NEMA 4X rated enclosure. You have 3 relays built in that operate independently of either the analog output or the backnet output. That's the main difference between these two. The Q5 gives you an analog output in addition to the relays, where the B5 over on the right is in the same package, but it gives you a backnet output in addition to the relays in the LCD display. And there's an audible alarm built in. I'm going to show a quick video that shows Dave Wisey, one of our technicians, testing and calibrating these Q5 sensors. We test before shipping, and I wanted to talk about the life expectancy of these sensors. Because these sensing elements are electrochemical, that means that there's a chemical reaction when the gas is detected in the space. And so as a result of that, the sensor will wear out over time. So these sensors do have a lifespan, and the higher the concentration of gas that's present in the air, the faster these sensors will wear out. So typical life expectancy for these units is 4 to 6 years, but that can be higher or longer or shorter based on the actual readings of gas that's present in the air. So these sensors do feature an ability to replace the sensing element down the road after they have worn out due to the electrochemical nature of the sensor. After they've worn out, you can easily replace the sensor by simply, there's 2 screws here on the circuit board. You can just pop this board out and pop in a new board that's pre-calibrated. So it's very quick and easy to replace the sensing element on this unit down the road. We've seen a lot of requirements recently for standalone gas sensing systems that operate independently of your BMS system. So in those cases, we can provide one of 2 different small control panels that operate directly with our gas sensors. The M controller is a small compact panel that can accept up to 32 digital inputs or 8 analog inputs and 8 analog outputs. And the Q controller over on the right-hand side of the screen can take up to 128 digital and 128 analog inputs. And both are easily configurable and programmable. And again, these are for applications where it's required to have a complete standalone system for your toxic gas measurements that operates completely independently of your the BMS system. We do have a solution for that, and we're happy to get you more information on that should you come across these requirements. We also have a infrared freon monitor for refrigerant leak detection. This again is a completely standalone system that can monitor all types of freons. It can be field programmed, so our distributor partners can have one version in stock, and then it can be programmed to detect all of the different types of freons that you may come across in the field. It's got an integral horn and strobe, and it also can use relays that are packaged on the board to sound an external strobe or alarm outside of the space where the refrigerant leak may be. Moving on to some of our high-end industrial grade explosion-proof toxic and combustible gas sensors. You see the 1710 series over on the left-hand side of your screen. This is for the hydrocarbon gases, and in both of these units, both the 1710 and the 6000 are without LCD, so these are a lower cost option. And so the 1710 is for the combustible gases like methane, hydrogen, gasoline, diesel, and things like that, whereas the 6000 series is going to cover your toxic gases like CO, NO2, oxygen, and ammonia, things like that. So these are Class 1, Div 1 rated explosion-proof enclosures. You can see these are a very sturdy, heavyweight enclosure to provide completely explosion-proof gas detection in these environments. We have also these versions available with LCD and some additional communicating features. The QTS 8000 and the Q8 again are both in Class 1 Div 1 explosion-proof rated enclosures. They have relay outputs. They can be programmed for either a parts per million output or a percentage of the lower explosive limit. So you can configure which output you want or which is required. You can do an analog 4 to 20 output or an LCD or the relay outputs, and these are all configurable through the LCD units on the screen. Here's our upcoming webinar scheduled next month, September 29th. Maya Holzmer is our pressure expert, and she's going to be going through our full line of pressure sensors. Maya is certainly our pressure expert. She's forgotten more about pressure transmitters than I'll ever know, and she'll be able to answer any questions that you have regarding our full line of pressure sensors. We also have the ability to do custom webinars for you if you'd want that. Instead of doing a broad or general webinar like this, we'd be happy to do a customer specific one. So if you're a distributor or if you're a Johnson Controls dealer, we can tailor a webinar specifically to you. We can use it to help train your employees as well. With that, we're going to open up the webinar to the Q&A session, and we'll go through and answer some of your questions. First question is, what is the typical coverage area that each of your sensors can monitor? And when we talk about coverage area, we're talking about toxic and combustible gases. CO2 is it's not toxic, so we don't typically run into specific coverage areas for CO2. But for toxic and combustible gases, the general recommendation, it depends on the specific gas. For the most common ones like CO and NO2, we recommend one sensor cover a maximum of 7,500 square feet. Some of the other gases that are more toxic, we might recommend one for every 5,000 square feet. But those are just general requirements. You want to take into consideration not just square feet, but cubic footage of the building and the overall shape of the building and any other sources of ventilation as well. But we do have some data, and we can get that information to you that lists all of the toxic and combustible gases that we have and what the recommended coverage areas are. What's the typical life expectancy for your sensors? Again, for CO2, the typical life expectancy is 15 years plus. The CO2 sensors don't wear out over time, and if you're using the ABC Logic software, there's no need for future or periodic recalibration or maintenance for those sensors. For the toxic and combustible sensors, most of them are electrochemical in nature, and they do wear out over time. So the typical life expectancy is anywhere from 4 to 6 years. We've seen them go well beyond that because it is based on the actual levels of gas in the space. So if you're in an area, if the sensors are in an area where there's high levels of CO, for example, that sensor will wear out faster. And I did want to mention, and I forgot to mention this before because a question does come up fairly regularly about lead times on these sensors. Because these sensors, a lot of the toxic and combustible gas sensors, they do wear out over time. As a result, they have a shelf life. So a lot of these sensors, there can be a little bit longer lead time on these sensors because we will build them to order compared to sensors like our temperature and humidity sensors that we typically have available or are available to turn around quickly. With that said, we do stock the most common gas sensors like CO and NO2 since those are very common. We typically have those available to ship ASAP. But if you've got a job that requires, hydrogen or ammonia or methane, some of the less common gases, we would typically build those to order, and so that might be an additional lead time. Typically, it's not more than a couple of weeks. And the reason we do that is, like I said, because these sensors have a shelf life. So we want you to have this sensor be in the field for 4 to 6 years and not have that life expectancy be taken up by sitting on our shelf or sitting on your shelf, and then the actual effective life expectancy might be 3 to 5 years instead of 4 to 6. Can your gas transmitters have the sensors replaced in the field? Yes, I should say yes for some of them. For CO2, no, those sensors are not replaceable. But for our toxic and combustible gas sensors, most of them are field replaceable. For the Q5 and B5, it's a very simple process to snap in a new sensor. There's 2 small screws that hold the sensor onto the back of the circuit board, and it snaps right in, and it comes pre-calibrated. But for CO2, that sensor doesn't wear out over time, and there's no need for a field replacement of a CO2 sensor. Most of the gas sensors can be field replaced. Next question is, how high should we be mounting the gas transmitters? Good question. We do have a recommended mounting height, and that's going to vary based on the specific gas that's being measured. And we base our recommended mounting height on the actual chemical weight of the gas. So, for example, CO gas is the same weight as ambient air. We would recommend that sensor be mounted 4 to 6 feet off of the floor where head height is. For example, NO2 gas is heavier than ambient air, so we recommend that gas be mounted at the floor or as low to the floor as possible, because over time that gas will sink to the floor, and that's typically where people are working as well. There is some debate about this in industry. For example, NO2 NO2 sensors is present in diesel exhaust, and so when exhaust is first exhausted from the car, it'll rise because it's hot, but as it cools, the gas will settle, and typically that's where people are working on or under vehicles. So we base it on the actual chemical weight of the gas. That's where we base our mounting height, and not on any changes in due to temperature of the gas. The question about CO2 sensor elements replaceable. I might have mentioned that a minute ago. For CO2 sensors, no, those elements are not replaceable. All of our CO2 sensors are backed by a 5-year warranty, and there's really no need for replacement of a CO2 sensor in the field. Typical life expectancy of our CO2 sensors is 15 years and beyond. And if there's an issue with that, we're certainly happy to work with you on that and replace anything under warranty if a sensor is not behaving properly within a 5-year warranty period. Next question: how often should I check to see if the transmitter should be recalibrated? And for CO2, if you're using the software, there's no need for future recalibration. For the toxic and combustible gas sensors, typically those do need to be recalibrated, and that we don't have a hard and fast requirement for recalibration. That's more so on the specs of the job. Most people require them to be recalibrated once a year, and there is an easy mechanism to test and recalibrate the toxic and combustible gas sensors. Most people do it using an inert gas like nitrogen, and there's a little device that can for the Q5s and B5s that snaps right onto the front, so you can and then hook the other end up to your gas tank hose and spray the gas directly onto the sensing element, and you can zero it out using an inert gas like nitrogen. But like I said, that is more often required at the job spec, how often they require recalibration. Can the QTS 1710 be programmed to indicate percentage of LEL? I believe it can. I will confirm that. I know the ones with LCD can be programmed either to a parts per million or a percentage of LEL. And I don't know if Rob Kapanos can comment on that, but I believe the 1710 can be programmed to a percentage of the lower explosive limit as well. A question: I have an existing LON talk system. Is there an option for LON gas detection, specifically CO, in addition to Modbus and BACnet? No, we don't have any type of LON output or a LON protocol for any of our gas sensors, and I don't know if that's available anywhere in the marketplace. Off the top of my head, I don't know of any LON-based or LON protocol gas sensors. So fortunately, it looks like LON is getting less and less common out there. So we simply, we just don't have an option for that, and I don't know if there is one available for you. Question about VOC sensors. Do you have a VOC sensor or transmitter? At this time, no, we don't. We're monitoring it. We're keeping our eyes on the marketplace for VOC sensors. As of now, the reason we don't have a VOC sensor is because there's no set industry standard, whether that's via ASHRAE or via national building codes, as to what levels of VOC sensors are considered hazardous, when is there a need for additional ventilation. So as it stands now, there's VOC sensors tell us something's present in the air. It doesn't tell you how much or even what it is. So right now we feel it's more effective to monitor a specific gas and a specific level of that gas than a broad VOC sensor. There's rumors that there may be some changes, or ASHRAE might put out a recommendation regarding VOC sensors, or set a standard or a guideline for that. And if and when that happens, you can bet that we'll have a solution for that. But as of now, just aren't sure what the usefulness or the benefit of VOC sensors are. Question: are your toxic and combustible gas sensors UL listed? No, they're low voltage, so they don't carry any UL listing for the complete unit. see if we can look at some other sensors here. Do you offer pre-measured calibration gases? No, we don't, and the main reason that we don't provide the calibration gas is because it's prohibitively expensive to ship it. So shipping tanks of gas is, they're considered hazardous materials, even if it's an inert gas, like nitrogen. Shipping tanks of pressurized gas, it's considered a hazardous material, and it's very expensive to ship it. You can't just put it on a UPS truck. So we recommend that people go to local gas supply or welding supply stores or places like Air Gas or Praxair or places like that, and then they can either get an inert gas like nitrogen or argon, or they can get the specific require calibration gas, whether it's CO or NO2. You can get those from those types of places as well. A question about NO2 and CO mounting height. I believe we answered that one already. And I don't see any other questions presently in the queue. So with that, we'll conclude our webinar today. Please post your comments and feedback via our LinkedIn page. You can search for us on LinkedIn and on Facebook. And if you've got comments and feedback, in addition, my contact info is on the screen, and I'm happy to get back to you right away. Thanks for watching, and we'll talk to you soon. Have a great day.